So now we are in chapter 3.2 and we are on factors and simplest form. First, let's start with the definition of a prime number. A prime number is a natural number that has exactly two different factors, one and itself. A composite number is any natural number other than one that is not prime. So a prime number is a number where if you were to break down its factors, it would be one and itself. Factors are numbers that you can multiply together to get another number. So for example, 2 times 3 gives us 6. 2 as well as a 3 represent the factors of 6. 6 is not a prime number because I can get 6 by doing 2 times 3. Whereas 5 is a prime number because the only way to get 5 would be 1 times 5. Another prime number would be 23. 1 times 23 is the only way that we can get 23 using multiplication. A number like 8 is not prime because we can get it by doing 2 times 4. Okay, so let's do some examples. It says determine whether each number is prime or composite, and then explain your answer. So, A says 16. So if it is a prime number, the only way we can calculate the number is by doing 1 times 16. Well, that's not the case with 16 because we can technically do 2 times 8, and that'll give us 16. Or we can do 4 times 4. That is also 16. Therefore, this is a composite number. And then for B, it says 31. Well, the only way we can get 31 is if we do 1 times 31. Therefore, 31 is prime. And then C is 49. We can do 7 times 7, and we'll have 49. Therefore, it is a composite number. Here's some tests for dividing a whole number. If the number is even, it is divisible by 2. So for example, 88 can be divided by 2, or 46 can be divided by 2. If the sum of the digits is divisible by 3, then the number is divisible by 3. So 93. If I take 9 and 3 and add them, we will get 12, and you can divide 12 by 3. Therefore, 93 can be divided by 3. If the last digit is a 0 or a 5, then the number can be divided by 5. And also, if the last digit is just a 0, the number is divisible by 10. Now, prime factorization is the factorization in which all factors are prime numbers. So you're going to take a number and break it all the way down to the product of its primes. So for example, if we did 8, well, the whole number 8 can be broken down into 2 times 4. 2 is a prime number, so I'm going to circle it to remind myself that it's prime. And then I need to break down the 4. 4 can be broken down by doing 2 times 2. And again, 2 is prime. So as 8 is really written as 2 times 2 times 2. So 2 times 2 times 2, which is 2 to the 3rd power. This is the prime factorization of 8. Every whole number greater than 1 has exactly one prime factorization. Now let's do some examples. It says find the prime factorization of 30. So starting with 30, let's break it down to two numbers that we can multiply together to get 30. So how about we do 15 times 2? 2 is prime, so I'm going to circle it. And then I'm going to break down 15, which is just 3 times 5. And 3 is prime, and 5 is prime. So the prime factorization of 30 is 2 times 3 times 5. And you can check it, because 2 times 3 is 6, times 5 is 30. Prime factorization of 36. Let's break down the 36. That's the same as saying 6 times 6. 6 is not prime, so let's keep going. That's 2 times 3 and 2 times 3. So the prime factorization of 36 is 2 to the second power times 3 to the second power. Okay, so now let's find the prime factorization of 63. So let's think of ways we can break down 63. Well, we can do 9 times 7. And then 7 is prime, so then 9 is 3 times 3. And the prime factorization would be 3 times 3 times 7, which is 3 squared times 7. Using prime factorization, we can write fractions in simplest form. You're going to break down the numerator and the denominator into its prime numbers, and then cancel any common factors between them. So for example, we have 10 over 42. So if you break it down into prime factorization, you're going to break down 10, which is 2 times 5. And then you're going to break down 42, which is 2 times 3 times 7. And then cancel any common factor. So the 2's would cancel out, leaving 5 over 21. That's one way of reducing a fraction into simplest form. Another method is to divide the top and the bottom by a common factor. So for example, we can do 10 divided by 2, and we also can do 42 divided by 2. 10 divided by 2 is 5, and 42 divided by 2 is 21. You'll receive the same answer either way you do it. And then for B, we have 9 over 27. 9 divides into both. So we have 1 over 3. And then for C, we have 8 divided by 36. Divide both by 4. So 8 divided by 4 is 2, and 36 divided by 4 is 9. Again, let's write in simplest form, 50 divided by 22. So a common factor between both of them, we can start with 2. They're both even, so we can divide both by 2. 50 divided by 2 is 25, and 22 divided by 2 is 11. So we have 25 over 11, and this is in simplest form. And then for B, we have 9 divided by 90. We can divide both by 9. And you'll have 1 divided by 10. And then for C, we have 35 divided by 75. They both end in 5, so we know we can divide by 5. And 35 over 5 is 7. And 75 over 5 is 15. And that's in simplest form. We have 7 over 15. Okay, so now let's practice a few more problems from our book. Let's go to page 192. And we're going to look at problem 63. And it says, a work shift for an employee at Starbucks consists of 8 hours. What fraction of the employee's work shift is represented by 2 hours? So remember, a fraction is written as the part over the total. Well, a part is 2 hours, and the total is 8 hours. So it's 2 over 8, and of course we have to reduce it, which means we'll divide both by 2. And we get 1 over 4. Let's look at number 65. It says, there are 5,280 feet in a mile. What fraction of a mile is represented by 2,640 feet? So again, remember the part divided by the total. The part is 2,640 divided by the total, which is 5,280. And then we get to simplify this. So let's start. When we have 0 over 0, we can cancel these out. So we have 264 divided by 528. Now we can divide both by 2 because both of them are even. And we'll get 132 divided by 264. Again, both are even, so we could divide by 2. How about instead, if we did 1 plus 3 plus 2, so 1 plus 3 plus 2 is 6, and that's divisible by 3. And then if we did 6 plus 3 plus 4, that is 12, and that's divisible by 3. So how about we divide both by 3 instead? So 132 divided by 3 is 44. And then 264 divided by 3 is 88. Then we can finish off by dividing both by 44, which is 1 over 2. Okay, so this will conclude our video for 3.2. Please email me if you have any questions.